Welcome back. In this block, we're going to start discussing data management, more specifically open and fair data, and especially why these two are not necessarily the same. And to get us started, let's discuss data availability policies. For years, publishers have required authors to make data publicly available together with the article publication. We have seen many publishers implement such policies with their publications and journals over time, but of course, this really gained traction when we started getting national and international mandates. So, for example, we know that Horizon Europe already mandates that almost all data be fair. And just last month, for example, the US government announced that federally funded papers and most underlying data generated should be made available. And the deadline for compliance is the end of 2025. And with all that movement towards actual and broader openness comes the question, why open data? Of course, there are several reasons, but let's focus on three here. The first one's transparency. We're talking about the democratic school of open science in the sense that everything that comes from research, publicly funded in most cases, can be accessed by everyone. So the result of the work is transparent. Also, you have the issue validation. If you open the data underlying publications in the scientific research conducted, reproducibility issues are addressed. So people can double check that research, they can validate that research, and then we can have better science, one could argue. And finally, it's about pragmatism, because you have different blocks in which you have to build science. So you build science on top of science, and these building blocks need to be shared. Else, what tends to happen is that you see a lot of researchers doing the same research or redoing work that's already being done. And with those aspects in mind, let's talk about fair data. What does it mean to be fair? So, the F stands for findable. Then we have accessible, interoperable, and reusable. And what does that mean for data in practice? So, being findable means that data should be findable by humans and computers, representing a series of procedures where the data need to be properly cataloged and properly described and defined in a way that people can actually find them. Not only machines or indexing services, but also people can understand what the data are and what they mean. Being accessible means that once found, humans need to know how data can be accessed. That is an important distinction. We will discuss a little bit more in a moment. The point is that being open is different from being fair, because data can be fair and not necessarily be open. Limitations may exist in some circumstances, but we'll come back to that. Interoperable. Mainly this means data need to work with accessible applications and adequate workflows. That means, for example, you should choose the type of file format you're sharing. So for instance, you can use free software that is broadly accessible and not software that may be out of reach for most people. And reusable means that data should be ready for future research and processing, and that means mostly documentation. So it means you need to inform what the data are, what they contain, and what you can do with them. That's an essential element you must consider in being fair. But okay, let's take a deeper look at being fair to understand it a little bit better. Coming back to the findable, the first thing that you need to think about findable data is that repositories should be used. There's no discussion today about that. The point is that there are many repositories, some very specialized, and you could use those repositories to share your data. More than that, data should be properly identified and described. What I mean by that is, imagine you are looking for a file on your computer, but you don't remember how you named it or where you saved it. And then you go to the computer, try different searches, open different files, trying to find the one that you're looking for, and no, that's not the one, or maybe that's the one, but it might be an old version, and so on. So most of us have already gone through something like that. And sometimes it is really challenging to track the different types of outputs from our work unless we apply meta to that. And that is why we need to properly identify and describe data so that not only us, but also others can find them and understand them and use them. Furthermore, persistent identifiers are used both for authors and data. So for authors, we are all very aware of ORCID and the benefits that it can have in terms of finding and crediting authors. So it's essential that data also have this kind of possibility. And for data, we have DOIs, the digital object identifiers, so well known within the science system, but usually associated with papers. But you can have DOIs for other types of objects, including data sets, and they should have one. Of course, if you're using repositories, they will have one. That's one of the benefits. And finally, metadata should be a resource, a vital resource. But what exactly is metadata? Metadata is the data about the data. So we're going to pretty much describe what are the data that we're talking about, that we're making accessible to a broader audience. Who created the data? So authorship information is a part of that. When and where that was done. So when did you create or collect the data? When did the research take place? What's the period of data coverage, and where was that conducted? Then we have how were they created? For example, what methods were applied? What sort of technology was used? And then why were they created? The point here is we need to understand the reasons, the motivation behind the development of data sets, because data sets that were created for a specific purpose sometimes are not suitable to other uses. So we need to understand the whys as well. And then I bring you here an interesting comment by Mark Musin, recently published in Nature. He said that without appropriate metadata, data sharing mandates are pointless. And that's an essential thing. Why? Because it's not always possible to share the data, but it's possible to share the metadata and make your sharing fair. That's a crucial element of openness that brings us back to the accessible part of being fair. When you talk about being accessible, you say that conditions or restrictions apply. Fair does not mean open. And one of the main reasons for that, many of you are quite aware of it, are the general data protection regulations. So in Europe, of course, there's GDPR. There are other variations of that across the world, but the point is that personal data is protected. So in some circumstances, you just can't share the data. It's not about you wanting things to be open. It's that the data do not belong to you. And even if you can get authorization on a person-by-person basis, there are limits. You cannot use that data for everything they could be used for. So this is one of the situations where you can say, okay, here's the description, here's the data about my data, here's the explanation of what they are, how they were collected or produced, and so on, but I cannot share the actual data. And why else would you not be able to share data? When does it need to be closed? Besides GDPR, you can think about intellectual property rights, for example. This is a big issue. They're thinking, for example, of patents for which the novelty aspect needs to be guaranteed by the fact that information was not previously shared, or else the patent is denied usually. So there are ways to deal with that, and we will come back to it, but it's one of the reasons why data can't be shared. Another point is that sometimes openness might jeopardize project objectives. So imagine you're working on a project with a team, and you're collecting a lot of data and preparing data for a series of analyses that you have to perform throughout the project. If you already shared all the data you collect in your first deliverable, for example, maybe other people could get the data and perform the analysis that you had planned to do yourself. So it makes sense that in this case, we may have a timeline to share the data, or we can share partial data as results are being published. Then we have, for example, commercial issues. Sometimes we need to use data sets in our research they're not ours, that we have to pay to have access to. And usually when that happens, we cannot share the microdata we have paid for. We can maybe share an aggregate form of it, but not necessarily the whole data set. In this case, of course, commercial issues prevent you from sharing. What you could do in some occasions, and Ludo will talk about open code in another block, is you could have your code open, making a reference to the commercial data set with the proper metadata, the proper description, and any user that's actually interested in replicating your research or building on top of your work can get the code and contact the commercial provider directly, pay for access to the data. So that's how things work. Finally, we have security-related issues. Data sometimes need to be protected, either because of national security or some other related matters. And in the current geopolitical situation we find ourselves in right now, I'm sure that's a very valid reason to keep some research privileged, so to say. But it is essential to mention that, despite not being open, the data remain fair if the proper metadata is shared, especially if you include paths and conditions so that the data can be accessed. So, coming back to being accessible, it is essential to rely on a proper ICT infrastructure for research. Usually, the institutions will provide that. Researchers can count on appropriate storage and get the necessary guidance and support for the data until it's ready to be shared. Another thing to consider is the choice of digital repositories, and you need to think of that from different aspects, such as the legal one, the trust one, and the longevity one. So, for example, one of the biggest mistakes we can make when sharing data is to use our own personal websites. Do you know if they are hosted according to local regulations? Maybe they're, I don't know, accessed from a server on the other side of the planet. Or do we trust our provider? I once had to rebuild a personal website because my original provider went out of business. Also, are researchers keeping their websites alive past retirement or a career change, for example? We need to trust repositories to do that for us instead. Okay? And then we have, of course, alternatives to openness, something that we have discussed already, but it makes a lot of sense to reinforce. If we cannot share the data, if the data cannot be opened, I must produce adequate metadata, and I can make myself available to interested parties so we can discuss an access alternative. So, moving on to interoperability. The first key issue we must consider is the choice of data formats and software, preferably open. So once again, compatibility of format is quite relevant. For instance, I'm a heavy user of R, and I love working with R data files. They're small, they're fast to read, to write, they can store complex objects, and R is open source, unlike many known mainstream statistical applications. So if I share a data set in R data format, I would be checking a lot of openness boxes. But I realize that researchers have different skill sets. R has a steep learning curve, and it would be a bit responsible from my side to assume everyone could just use my files. So I prefer to export everything as CSVs for sharing, which, by the way, is preferable to Excel files. After all, Excel is a commercial software, and there are some institutions that favor open source alternatives. Okay, so we have, of course, the need to apply metadata standards, and we discussed metadata already, but in this case, I'm talking about community standards that apply. And I included a hashtag here because I was thinking about an example to illustrate that thought, that is using Twitter during events. Let's say you go to a conference and there is an official hashtag of the event. Then you can use that hashtag to look for related tweets, and you can use to tweet yourself, and that way everybody has access to everything that's being posted about it. But if you choose a different hashtag that only you know, no one will see your tweets, and you won't see anybody else's tweets as well. So from this quite simple example, we can see it's necessary to think about normalized and standardized metadata so data can be shared, found, understood, and more importantly, broadly used. For example, the Dublin Core is one of the most widespread metadata standards available as of now, and I encourage you to check it out. It's worthy. And last but not least, I reinforce that open code is a plus. Once again, Ludo will take up that discussion in a separate block, but the point is that sometimes you share the data, and if you don't share the code to deal with that data, its value may be reduced. Then let's talk a little bit more about reusability. And here I have included an image of apples and oranges, because that represents an idea of two things that cannot really be compared despite existing similarities. Imagine I have a recipe for orange juice, that's the open code, but I have apples as data, loosely defined here as fruit in my metadata. Of course, I will not get what I expect as a result if I follow the recipe's instruction to make my juice. So the starting point of reusability is that documentation is key. You should describe your apples and oranges, and that has to be done in three levels: project, file, and item level. What is a project? What is the research about? What is the description we need to understand the context of that research? Then we go to the file. Each file needs to be properly described, what it contains, how it was created, why it was created, and then you go to each variable, what each item represents. Then you have provenance information that's also quite important. Where did the data come from? How was that created? How was that collected? How was that processed? And why, for example? And at the same time, we must say what a data set is. We should say what it isn't. It is crucial to include limitation information because it shows the extent of the value of that data so that future users may not extrapolate its usefulness. And then, of course, you need to think about being clear with the license for reuse. Just remembering very briefly something that Tad discussed in a previous video, we have here the Creative Commons licenses grouped according to how open they are. The most open license is CC0, meaning you can do whatever you want with the data without even the need to give credit to the original authors. Then we have CC BY that you need to give credit, and a bunch of other variations that in most cases do not make a lot of sense for data. As with everything, there's a lot of debate regarding the best license to share data, and some groups push for the use of CC0 especially. But I would say that for now, the general recommendation is to go with CC BY. More than acknowledging authorship, crediting authors is a question of provenance in the case of data. And with that, let's close this blog with a contribution from one of our open science champions, Marianne Grootveld, who will discuss some of the issues presented today in practice, considering her experience as a policy officer dealing with the whole concept of fair data in her workspace. Let's hear from Marianne.
My name is Marianne Grootveld. I work at DANS, Data Archiving and Networked Services, which is an institute of national expertise on data, an institute of the Royal Dutch Academy for Arts and Sciences and NWO, the Dutch research funder. My role there is leader of the team of research data experts. We deal with the archiving side, but also with the keeping the data fair and open for reuse in the long term. We can think about open data from the supply side and from the demand side. At the supply side, we have projects and researchers who generate or produce the data and provide them. At the demand side, we have researchers and hopefully citizen scientists who are interested in using existing data. We could also label them producers and consumers. An important place where the data producers and consumers meet is the data repository. Producers deposit their data, consumers search the catalog and download the data. This basic model is in place. There are at least 3,000 research data repositories worldwide. within research infrastructures or independent, with an institutional, a national or an international scope. But for the model to work, we need more, we need trust. My claim is that openness is based on trust. Data producers need to be able to trust that their data will not be misinterpreted, and also that they get credited for their work. And by the way, this is also important for research funders and the researchers' employers like the universities. Potential consumers, on the other hand, want to be able to trust that the data are reliable and usable. Uncertainty about the data provenance or data management, where do they come from, how have they been cleaned, etc. Not knowing this is killing for actual reuse of data. The need for trust implies that just opening up the data for others isn't enough, although it is a crucial step. What is needed in addition is contextual information. You can think of documentation about selecting interviewees or machine settings, codebooks that explain variables, definitions that are used, statistical queries, software perhaps that is needed to access the data. All of these types of documentation and metadata fit under the umbrella of the FAIR data principles. Data should be findable, accessible, interoperable with other data sources, and reusable. I think that the notion and the relationships between the notions of open and fair data is clear to you. But when in doubt, I would recommend as a motto, open when possible, restricted when necessary, and always fair. Now, researchers sometimes find that fair data management is something extra, yet another thing they want me to do. And granted, many principal investigators and project teams put a lot of effort into making the data as fair as possible before they publish them in a repository. But let me mention two very valuable resources that can support them: data stewards and repositories. Data stewards are the relatively new kid on the block when we talk about research support. Lab staff, librarians, legal and IT departments have been around longer to provide researchers with their data. I really hope that all of them will benefit from the trend to recognize and reward contributions to research. We certainly haven't seen enough effective reward mechanisms, but there are interesting examples, such as being co-author of a publication and contributor to the underlying dataset awards, and job descriptions with clear career paths. Also, you could consider rewarding a project team for the excellent implementation of a data management plan by recommending the plan as a good example for others. Let me then return to the topic of repositories and trust and end this presentation. Long before the FAIR principles were introduced in 2014, long even before open data and open access emerged and got traction, there were researchers who deposited their data in a repository, often on their own initiative and for the public good. Repositories have a worldwide certification mechanism in place to evaluate and show when we can trust them to preserve the valuable, open and fair data for long-term reuse. Going back then to the simple model of data producers and data consumers, I'd like to summarize this in a third motto: open and fair data live in trustworthy repositories.
And with that stimulating contribution, we close this block, but we follow in the next one with a discussion on data management plans.